All right, informal geometry and measurement, section 1.2. All right, so like I said, there's some things that in these videos that are literally stuff that you could read off here. Just maybe adding a voice to it will help some. So like, why is he just reading off the slide? That's why. So in geometry, the terms point, line, and plane are described, but not necessarily defined. So what we want to do is make sure we understand those, and so that when we use them, we've got an understanding of what we're actually talking about. Other concepts that are accepted intuitively but never defined are what it means to be the idea of straightness of a line or the flatness of a plane. There's the notion that a point on a line lies between two other points on the line, and the notion that we have an interior of an angle and an exterior of the angle. So we just like can use these, like these ideas. So let's go and take a look at like what point, line, and plane actually means. All right. So points. These are descriptions of some of the undefined terms. So a point, which is represented by a dot, it has a location but not a size. It's a point with no dimensions, right? So it just depends on how, because it's just one thing. I mean, when you think about for yourself, you can draw a point with a little dot. You could draw a point where you draw the dot and you fill it in, So like, if we think about it like this way, like that could be a point. This could be a point. That could be a point, right? And so that's kind of the idea. When we label, it has location but not size, no dimensions, and uppercase italic letter is used. So the proper math grammar for points is going to be a capital italicized letter. A line. This is where the two things come together, because what a line is just an infinite set of points. Given any 2 points on a line, there's always a point that lies between them. Now, it may not be to like your naked eye. And what I mean by that is like, for example, like if I put a point right here and a point, I'll just change colors real quickly, a point right here, then what they're saying is that we can always put another point in between like that. And then we can always put another point in between there like that and like that and like that and like that and like that. And even though like to us, we can't really see that it's and there's an additional points going in there, because to the naked eye, if we zoomed in and went to like an infinite zoom, there's still going to be space for more points to go in between. The first definition here is this idea that it's infinite set. So like if we have a point and a point, all a line is just points, 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 just filling in. So a line is nothing more than an infinite number of points. Lines have a quality of straightness. So that's that word straightness coming into play. That is just understood that if you're a line inside of, and I will say this, I'm not going to go in the depth of this, but like inside of just our informal geometry that we're doing, lines have straightness. When we get on to other spaces and more advanced math classes, we'll get to a situation where a line doesn't necessarily have to be straight, but it'll be defined as being in a different space or a different organization. All right, given several points on a line, these points form a straight path. Note, whereas all points have no dimension, a line is one-dimensional. So even though a point has no dimension, a line is one-dimensional because it has length, or it has width, or it has height, right? One of the two, depends on how you think about it, right? So it'd be like length that way, it'd be height that way, and then width doesn't really make sense. It's not like how fat the line is, but like width of a two-dimensional shape or something. A line. Line AB represented by the symbols AB. Notice that it has a symbol across the top. That symbol across the top is signifying that this line goes forever to the left and this line goes forever to the right. It extends infinitely in opposite directions, as suggested by those arrows. And so if we wanted to identify line AB, it'd be written as the AB with the line over top. This is what it looked like. So this would be an example of AB. We also could call it M. So we could just like give it a single lowercase letter, italicized, and that would also signify a line, line M. Note the position of point X on AB, where when 3 points such as AXB are on the same line, they're called collinear. So there's a great vocabulary word for you to add to your notes. Collinear. Collinear just means that they're on the same line. All right. In order to show symbolism, we can do AXB or BXA, but it's not going to be, sorry about that, it's not going to be XBA because X is in between B and A. So that would be an inaccurate representation. When drawing is not provided, the notation ABC means that these points are collinear with B between A and C, like I just said in the last slide. Sorry about that. When drawing is provided, we assume that all points in the drawing appear to be collinear are collinear unless otherwise stated. So for example, in figure 1.9D, we can see that's collinear. In figure 1.8, these are not collinear because they don't form a straight line. So this is that whole acceptance of what it means to be on a line, and a line is assumed to be straight. And so there's no straight line that we could draw that would hit A, B, and C. So therefore, they're not collinear. At this time, we formally introduced some terms that will be used later. You have probably encountered the terms angle, triangle, and rectangle many times. As an example of each of these is shown in figure 1.1. Using symbols, we refer to the figures in 1.1, A, B, and C as angle, ABC. So you can see the symbolism there. Let's see if I can get this particular computer is a little laggy with my little tablet. So we write that as angle, A, B, C. I like to put like a little mark through the angle right there because what that signifies to me is that's not an inequality symbol, it's an angle symbol. So you'll see that both ways, depends on who the author is or the professor. And then we have triangle. So this little symbol right here stands for triangle. So it's read as triangle, DEF. So triangle DEF. Could also be triangle EFD, could be triangle DFE, it could be triangle FDE, and so forth and so on. And then we can also use a rectangle and call it rectangle WXYZ. And same thing, it doesn't have to start with W, you can start with any one of the vertices, but it must go in order. Just like with the angle, it's got to go A, B, C, because B is the vertex. So it's got to be, B has to be between the two sides. Some caution must be used in naming, and I probably have already talked about this. Let's see if yeah. So this is what I kind of talked about is, oops, sorry about that, is that like in an angle ABC, B has to be in the middle. So we can definitely call this CBA or ABC, but we can't call it BCA because B is the vertex. It's got to be in the middle. We also can just put a number in inside the angle and just call it angle 1. Same thing with triangles. We can identify it. We have lots of vertices. Doesn't matter which way. We're just identifying. The same thing with the rectangle. Sorry that I forgot that I had that slide right there. Line segment. A line segment is a part of a line. So notice in a line segment, it doesn't go on forever. It stops. There's two distinct points that act as the endpoints on that line. By using the symbol, the straight line, notice there's no arrows on top. It's just a straight line. That signifies that this guy starts at B and goes to C, or starts at C and goes to B, and it doesn't go on beyond that. We use BC. Notice the segment symbol is gone to indicate the length of a line segment. All right, so these are just like terminology things. I mean, it's probably good to jot down some of this stuff on your notes, but I mean, you have this as a reference. Maybe you have some background knowledge already of this, so that's why I like just printing this out, so then you have this as one particular document. All right. All right, so the question is, we have a rectangle. This is just kind of testing, so if you want to hit pause, I guess the answer is already at the bottom, but we can see here X, Y, Z, W. X, Y, Z, W. Perfect. Goes in order X, Y, Z, W. So yes, that works. All right, the next one. W, Y, X, Z. W, and then it goes diagonal. And that diagonal is not a part of the rectangle. So that's what breaks the rule. That's why it cannot be named W, Y, X, Z, because we're zigzagging across it. All right. So we're going to stop there and we'll start up a new video for measuring line segments.